In the previous video, I was talking about t-tests and how the experimental design we use determines what kind of t-test we need to run. Specifically, I showed you how to do a paired samples t-test, which you do when you gather multiple measurements from the same group of people. The other way to do it, which I'm going to go over now, is how to compare measurements obtained from different groups of people. This is called an independent samples t-test. So I'll reuse the same data from the previous video, but I'll rename the variables. Instead of pre-college IQ, I'll say these scores are the IQ scores of people who had no college. And these people represent the IQ scores, or these represent the IQ scores of people who did go to college. So the process of doing the independent samples t-test is pretty similar. You go to Analyze, Compare Means, and do independent samples t-test. Now at this point, it's different from a paired samples t-test. You can try moving the variables over, but when you try and run the analysis and click OK, it's not letting you do it. Something's wrong here. The thing that's wrong is you need to set up the data differently for an independent samples t-test. This way is great for paired samples, won't work for independent samples t-test. See, with a paired samples t-test, this pairing is very important. This is a person's IQ score before they went to college. This is that same person's IQ score after they went to college. But that pairing has no basis for independent samples t-test. This is one person, this is a different person. So when you run an independent samples t-test, you need to have all your IQ scores or all your dependent variable measurements in one column. So I'll do that, I'll call that IQ scores. And I'll just take these and put them all in the same column. The way I differentiate which one of these IQ scores came from college graduates and which ones came from non-college graduates is I create another column where I code for group membership. And the way I do that can be simple. I'll say the people who did not go to college, they're ones. People who did go to college, they're twos. And if I'm so inclined, I can even go to variable view and create data labels, value labels, where 1 means no college and 2 means college. So there we go, I have it nicely labeled. And we did a really similar to this in the frequency counts video. So now that we have all our scores in one column, I don't need these things anymore, they're useless. We have all our scores in one variable. We have our coding scheme as another variable. Now we can do the independent samples t-test. Just go to Analyze, Compare Means, Independent Samples. When the window pops up, move over your dependent variable, which is your scores, under Test Variable. And move whatever variable we have that contains the coding scheme for group membership into the thing that says Group Variable. Now you'll notice I can't run the analysis yet. The OK button is still faded. It's because under grouping variable I have little question marks. SPSS doesn't know what our coding scheme is. We have to tell it. Click Define Groups and tell it. Group 1 we labeled with a 1. Group 2 we labeled with a 2. Hit Continue. Now we can run the analysis. Hit OK. And our output window pops up. Just like before, we get one table with descriptive stats. It tells the sample size, the mean, the standard deviation, the standard error for each one of our groups of people, no college education versus college graduates. And below that, we see the table containing the inferential statistics. And you can mostly focus on this middle part of the table. We have the t-score, the degrees of freedom for our two groups, and the p-value that corresponds to that t-score at those degrees of freedom. Which we use to determine if there's a significant difference or not. If p is less than 0.05, we can say, yes, there is a significant difference. What is that difference? Just look at the means. It looks like the college graduates on average have higher IQ scores than the non-college graduates. Over to the right, we see the confidence intervals, which tell us the range of differences that likely contain the real mean difference in IQ scores for our populations. Everybody in the world who's a college graduate versus everybody in the world who is not a college graduate, instead of just the samples of 20 people we used. So that's about it. The last thing I want to mention is that there are two different rows with different results for equal variances assumed and equal variances not assumed. If you're new to stats and you have no idea what equal variances means, just don't worry about it. For the most part, assuming equal variances is okay, so just stick with this first row. So that's about it. One last thing I want to mention is that in the spreadsheet, these scores don't need to be in any particular order. You don't even need to group the college graduates separately from the non-college graduates. I can prove that. If you go up to Data and do Sort Cases and sort by IQ scores in ascending order, it'll kind of jumble up all the scores. Now I have some no college graduates, a few college graduates interspersed with no college graduates. If I go back and rerun the analysis, I get exactly the same thing. So the order I pop these things in really doesn't matter. So that's about it for t-test and SPSS. You just follow the menu options, which is pretty easy. The only trick is knowing what kind of experimental design you used and setting up your data properly. Particularly for independent samples t-test, make sure all your dependent variable measurements are in one column, and you have another column that contains a coding scheme for group membership.